Hi everyone, this is Anu. Me and my teammate Chandu worked on insider threat detection, dealing with feature engineering and sampling techniques. Firstly, let me define insider threat. Insider threats are malicious acts carried out by organizations' employees who abuse the authorized access to system and data through carelessness or revenge. For this project, we used CMU's CERT dataset version 4.2 as it has more insider threat incidents than the others. It consists of four different events: log on log off events, email transmissions, devices, and files. The ID here refers to user ID, and activity is log on log off, connect or disconnect, etc. And date here refers to the date of occurrence of the event. These are some of the previous models which are used in the insider threat domain. So we see that the highest accuracy attained is 94.5% using graph convolution networks. The second highest is 94% using random forest with randomization. So this is our data set, and we see that there are 1000 employees, of which only 70 people are insiders. Therefore, the data set is highly imbalanced. So all the previous work lacked balancing techniques as the data is imbalanced towards non-malicious records. Our research goal is to focus on these techniques as well as feature extraction and to compare our work with previous work. We also evaluated accuracy post balancing techniques. The first step is feature extraction. We extracted 17 different features from the .csv files provided and then aggregated these features with user ID and date. We then counted the frequency of each feature for a particular user and identified it as malicious and non-malicious based on the criteria defined by us. This gave us a target column that is 1 for malicious and 0 for non-malicious users. These are the 17 features which we derived. So here everything that ends with underscore normal or non-malicious. Non-malicious. These include a variety of features like when the user is logging, either he is logging between 8 a.m. to 5 p.m. or after office hours, whether the user is logging during the weekdays or the weekends, and if the type of files that are sent between the users. We also take into consideration if the emails are sent within the organization or outside the organization. We then proceed to vectorization. Here we created a 3D matrix where for every user we created a 2D matrix with the 17 features as the rows and the number of days that the user worked as the columns. We later on reduced it to a 2D array which yields us 9000 features per user in the data frame. To balance the target classes, we employed these four sampling techniques. SMART analysis. This is a common technique adopted in every paper. The other one is ADASN, that is Adaptive Synthetic Sampling Approach. SMART plus ENN, Editor Nearest Neighbor, and SMART plus Tomic Links. Tomic Links is a form of condensed nearest neighbors. We selected logistic regression, SVC, random forest, AdaBoost, isolation forest, and convolution neural networks as our models because they offer adaptability and flexibility for imbalanced datasets. We evaluated all our models on these following metrics, which are accuracy, precision, recall, and F1 score. Coming to our experimental results, we first performed SMART analysis on all our models. So SMART analysis adds synthetic data and is an oversampling technique. So and in this we see that logistic regression and SVC attain highest accuracy of 95%, followed by CNN with an accuracy of 94%. The second technique which we used is ADASN. ADASN is adaptive synthetic sampling technique. It is also an oversampling technique, but this takes care of distributed density. Using ADASN, the highest accuracy attained is 96% with convolution neural networks. The second highest is 94% with logistic regression and SVC. The third technique used is SMART plus Tomic Link. SMART technique, as I already mentioned, is an oversampling technique. So this can induce some artificial data leading to the overfitting of the model. So in Tomic Link, we choose random data from majority class. And if the random data's nearest neighbor is the data from the minority class, then it removes it, therefore performing undersampling. Tomic Link is a data cleaning technique that focuses on eliminating borderline instances that cause ambiguity. Using this model, we got an accuracy of 95% for both CNN and logistic regression, and second highest is 92% attained using SVC. The last technique employed is SMART plus ENN. This is also a hybridization technique, just like the previous one. But in ENN, the nearest neighbor of each of the majority class is estimated. If these nearest neighbors are misclassified, that particular instance of the majority class then gets deleted. So this technique majorly focuses on eliminating noisy synthetic samples. And in this technique as well, we see that CNN attained the highest accuracy of 95%, followed by SVC and logistic regression, which got an accuracy of 93%. Finally, for the same dataset that we used and the model which I already showed previously, we see that our model, which is a combination of Adason sampling technique plus convolution neural network, got an accuracy of 96%, which is highest among all the previous models. In conclusion, we tackled classes imbalancing using 4 techniques. And we also saw that Adason combined with CNN gave us highest accuracy of 96%. They also note that CNN always attained highest accuracy in every sampling techniques, followed by logistic regression and SVC. Furthermore, we would like to explore other datasets in real time and investigate deep feature synthesis in diverse domains. Thank you.